All right, so 4.2, today we're talking about dilations and scale factors. Another review day, stuff that you've seen or should have seen, right? We've talked about it before. Not every teacher gets to every topic they're supposed to teach every year. And so there's a chance that you've never seen this one before. So we'll do a quick review and make sure that you all are comfortable with this topic before we move on. So, vocabulary on the left and these images over here on the right. This little picture of, you've got a coordinate, I guess not a coordinate grid, but you've got a grid with a couple of triangles with labels on them, a point P, and we're going to connect these triangles to the vocabulary. So a pre-image, when we are talking about dilations, basically what you are doing is you're taking a image, you're taking an object and you are dilating it, which means you are either blowing it up and making it a larger version of the original, or you're shrinking it down and making it a smaller version of the original. Now, certain characteristics are going to stay the same as you blow up or shrink down shapes. We're not going to get into a lot of those today. You've studied them in the past, so there might be relationships you already know. But it's kind of like taking a scale model, right? If you, maybe you've built a model airplane or a model car with one of your parents. It's supposed to be a replica of a larger image, but shrunk down and made so that you can build it in your bedroom and put it on your shelf, right? So the way that you know the original figure, the points are labeled with the regular alphabet letters. All right, so capital A, capital B, capital C is, if it's a triangle, those would be the letters that we used. So this smaller triangle right here would be the pre-image. And I know that because of the ABC, not because it's smaller. The pre-image is not always smaller than the image. Now, the bigger triangle to the right, we know that it's the image. It's a copy. It's a blown up version of the little triangle on the left because of these little apostrophes. We read this B prime. In math, that apostrophe, you don't say B apostrophe, you say B prime, A prime, C prime. So we know that this is the image. This is the blown up copy of the original pre-image over to the left. Now, when you dilate something, you always have a center. A lot of times on the ACT, the center is just the origin if you're doing this on a graph. But it determines where the image will project, like which direction the image is going to go, is kind of determined by the center of dilation in relationship to the pre-image. So don't worry too much about that. In this case, the center is this point P over here. That's the center of this image. Now, the scale factor is basically what you multiplied the original by to get the new image. So if your new image is larger, if the image is larger than the pre-image, then you multiplied by a number bigger than 1. That's how we blow things up. We make them twice as big by multiplying everything by 2. We make it 10 times as big by multiplying everything by 10. If we want the pre-image to go smaller, then we would multiply by a fraction. So if I wanted like when you're doing a model car, you're taking you're making a model of a larger real world object. So you're shrinking the object down to get that image, to get that model car, which means your scale factor would be smaller than 1. It would be 1/20th or 1/10th or 1/12th, depending on the model car that you're building. All right, now to find the scale factor, something you've done a lot, clear back into elementary school, is you've got to be really careful which number goes where. To find the scale factor, we usually use the letter K to represent the scale factor. In the problem up above, it's easy to see that my image went from small to big. So my image is getting bigger, and if I look at the lengths of the parts of my original object is 1, 2, 3 wide, and my new object is 1, 2, 3, 4, 5, 6, 7, 8, 9 wide. So the formula down below tells you to take the image to find the scale factor. You take the image length, the new one, and divide it by the original, the pre-image, the old image length, which would give you a scale factor of 3. So image length, if you want to write new next to this, so you remember it's the new shape, not the original. And the pre-image, remember that's the original image. Another way to find that is to measure the distance from the center point to the image for both of these. So you would measure the distance from P to P prime and put that on top, and then measure the distance from P to B and put that on the bottom. All right. One thing I want you to note is, and this may, again, go back to something you've maybe learned in the past. You don't have to draw this on your paper, but one thing I want you to notice is my center P over here. If I draw a line from P and I connect it to my image B prime, if I make that connection, notice that my line goes through B, which is kind of cool. If I take my center and I connect it to A prime, then notice that it goes through the original point A. And if I connect the center to C prime, it will also go through the original point C. So your center, when you connect it to your image, you should always go through the pre-image. If your shape got smaller, it goes the other way around. But your image, your pre-image, and your center should all connect together on a straight line for all of your points. And we're going to use that a little bit later to help us do some math. All right, let's do some examples. Perform the dilation of triangle ABC. Oh, you know what? We didn't go over how to do the math. If it wants us to dilate an object, a shape, what it means is you take the original, the pre-image shape, and you multiply it by the scale factor. If the original image is if the original object is a point, then you would take the X and the Y values and you would multiply them by the scale factor to get the new X and Y value. So like up here above, those aren't really X, Y values. Let's just do this in example A, down here below. So it gives me a pre-image, ABC, so this is my pre-image, and it wants me to dilate it, so it wants me to make a new image by a scale factor of 1.5, all right? Now, one of the ways to do this is I'm going to take all of the distances of my original and I'm going to multiply them by 1.5. So for example, my center is right here, P. I don't really like that it has us starting this without a coordinate, but that's okay. I've got P as my center, and to get to A, I go straight over 1, 2, 3, 4. That's how I get to my original. I go 4 to the left. Now to figure out my new image, my dilation, I take that distance and I multiply it by 1.5, which gives me 6. So that means my new image should be 6 over from P. So instead of only going 4 over, I'm going to go 1, 2, 3, 4, 5, 6. And that's where I would put A prime. All right, now I can do the same thing with B. B goes down 1, but I don't want it to be the original. I want it to be multiplied by 1.5. So if I do 1 times 1.5, I get 1.5. So that means my new image is going to go down 1.5 But I'm not at B because I also have to go over. So to get over to B, I go over 1, 2. Well, to get to my original, I should have gone over, I go over 1 over 2 to get to my original B. So that means after I go down 1.5 for my image, I need to go over 2 multiplied by 1.5, which is equal to 3. So my new image, maybe I should do my new ones in blue so we're not confused here. My new image, I'm going to go down 1.5, and then I'm going to go over 1, 2, 3, and I'm going to put a dot right there. So my new B, my B prime, is going to be right there. Now I'm going to erase this one and this one and this one. Now C is down 1, 2. So the original C goes down 2, which means my C prime needs to go down 2 times 1.5, which is 3. So P prime or C prime is going to go down 1, 2, 3. And then over, let's see, C goes 1, 2, 3, 4, 5, 6, 7, 8. So to figure out C prime, I've got to take 8 and times it by 1.5, and that gives me 12. So I need to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's going to give me my new point C prime. And now I can erase all this other stuff that I don't need. So my new triangle, my image, once I connect these, whoa, that was a bad line. Once I connect those, my image is bigger and it slid over to the left a little bit because that's the direction that it enlarged from based on my origin. Okay, part B, identify the center and the scale factor of the dilation illustrated below. All right, so I can't really do either. I can't find the scale factor until I find the center. All right, and here's where I'm going to go back to what I showed you above, where the center connects B and B prime together. I'm going to do that down here. To find the center, I'm going to actually go backwards because I don't know where it is. What I'm going to do is I'm going to draw a line from A prime, and I'm going to go through A, and I'm going to make it really long. I just want a line that connects those two. Then I'm going to go from C prime, and I'm going to go through C, and I'm going to make that one really long as well. And then I'm going to get B prime, and I'm going to draw a line going through B. And what I'm looking for is where those three intersect each other. That tells me where my origin is. So I can erase those lines, and now, whoops, I just erased it. My center is right here. So that's my center P. Now to figure out my scale, I need to know, instead of just going from here to C, how much farther do I need to go to get to C? To C prime. So to get to C, I go down 1, 2, 3. But to get to C prime, I go down 1, 2, 3, 4, 5, 6. So K is equal to the distance to the image, 6, divided by the distance to the original, 3, which equals 2. Now notice I could have gone to any of these points. Instead of going straight down, I could have gone, and instead of using C, I could have gone over to A, 1, 2, 3, 4, 5. And then A prime is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's over 10. So 10 divided by 5 is also 2. So it doesn't matter which point I go to. It doesn't even matter which direction I go. I don't have to go at a diagonal. I can just count the straight across and the straight up and down to figure out how far, what my dilation is. Okay, so it's twice as big as the original. All right, let's go to C. Perform the dilation of triangle XYZ centered at P with a scale factor of 1/3. All right, so I want to go, instead of going all the way to X, I'm using a scale factor of 1/3. So let's figure out, first of all, how far do I go to get to X? I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how far it takes me to get to the original X. Now, if I take my scale factor, 1/3, and I times that by the distance 9, I end up with 3, which means my new X is only going to be over 1, 2, 3. So X prime is going to be right there at 3. Okay, let's do the same thing. Let's go to Z. So to get to Z, I go down 1, 2, 3, and I go over 1, 2, I'm going to put a 3 right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I go down 3 over 12. Now let's multiply those numbers by 1/3. So 1/3 times 3 is equal to 1. 1/3 times 12 is equal to 4. So that means to get to Z prime, I'm going to go down 1, and I'm going to go over 4. 1, 2, 3, 4. And I'm going to put a dot right there and call that Z prime. Now to get to Y prime, let's look at how I get to Y. To get to Y, I go up 1, 2, 3, just like going down to Z. And I go over 1, 2, 3, 4. I think it's going to be 12, but I'm going to count to be careful. 5, 6, 7, 8, 9, 10, 11, 12. So that is 12, which means it's going to change the same amount as Z. It's going to go 12 times 1/3, which is 4 to the right, and it's going to go 3 times 1/3 up, which is equal to 1. So it's going to go up 1, and it's going to go 1, 2, 3, 4 to the right, and this is going to be Y prime. So now if I erase all that nonsense, and I connect my blue dots, I have a dilation X, Y prime, Z prime of my original XYZ triangle. Okay. All right, given the point G, which is -4, 12, find G prime dilated by a scale factor of 5/4. Well, that's easy. I don't even have to count because it gives me the numbers right there. So G prime is going to equal, I've just got to multiply both of these numbers by 5/4. So I'm going to get 5/4 multiplied by -1, comma, 5/4 multiplied by 12, and that's going to be my new point. So G prime is, let's see, 5/4 times negative, that was supposed to be a 4. What happened to my 4? 5/4 times -4 is -5. 5/4 times 12 is going to be 15, I believe. So the point G prime is at -5, 15 if I dilate by a factor of 5/4. Given the segment UV, where U is 5/8 and V is -9, 2, find U prime and V prime if you dilate 4.5. All right, so U prime is going to be 5 multiplied by 4.5, comma, 8 multiplied by 4.5. And V prime is going to be -9 multiplied by 4.5 and 2 multiplied by 4.5. So U prime is, I better make that look more like a U, huh? U prime, 5 times 4.5 is going to be 22.5. I hope my math's right. 8 times 4.5 is going to be, let's see, 32 plus a half, 36. So U prime is going to be the point 22.5 and 36. V prime is negative 9 times 4.5. So negative 9 times 4 is negative 36 plus another 4.5, so negative 40.5. 2 times 4.5 is 9. So there's my new prime dilation points. Okay, your turn. You're going to do a little bit of everything. It's going to give you a center, and it's going to ask you to dilate a shape. It's going to give you two shapes and ask you to find the center and ask you to find the scale factor. And then it's going to give you a few word problems without the picture to help you out. Come see me if you have any problems.